In most cells, the chemicals that generate the electricity are contained in the electrodes and the electrolyte that form the cell. In a fuel cell, the chemicals are stored separately outside the cell and fed in when the electricity is required. One example of this is the hydrogen-oxygen fuel cell, which can be used to power electric vehicles.
The vast majority of vehicles today run on hydrocarbon-based fossil fuels, petrol and diesel for example, in internal combustion engines.
The price of these fuels is rising as supplies diminish and there is an increasing concern about the effect their emissions have on the environment.
Burning hydrocarbons in air produces carbon dioxide, a greenhouse gas, and acidic nitrogen oxides caused by nitrogen and oxygen from the air combining at the high temperatures in the engine.
One alternative fuel is hydrogen. This could be burned in the same way as hydrocarbons, but there is an alternative, a fuel cell.
This uses hydrogen and oxygen as fuels to produce electricity to drive an electric motor.
The fuel cell consists of two platinum-based electrodes separated by a special polymer electrolyte which allows ions to pass through. The top half equation is for the left electrode, the bottom half equation is for the right.
The electrons flow through an electrical circuit where they can power a motor. The H+ ions flow through the electrolyte to a second electrode. Here they react with oxygen and electrons to form water, which is the only emission from the unit.
As well as used in road transport, hydrogen fuel cells have been used in manned spacecraft, where the astronauts can drink the water produced.
At first sight, this type of fuel cell appears to be very green because the only product is water. However, we have to consider the source of all the hydrogen. At present, most hydrogen is made from crude oil, a non-renewable resource. It also made by electrolysis of water, but most electricity is made by burning fossil fuels which emit carbon dioxide.
Also,
hydrogen-powered vehicles will need an infrastructure of hydrogen filling stations to be built, which also raises the issues of storing and transporting a highly flammable gas. For example, in the 1930s, two airships which used hydrogen as their lifting gas, the Hindenburg and the R-101, exploded with serious loss of life.
The idea of using hydrogen as a fuel is not new. It was a component of town gas, which was supplied to UK homes until replaced by North Sea gas in the early 1970s.
Yeah. In most cells, the chemicals that fuck. In a fuel cell that you're in the camera like woo! Definitely should. La 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 la. Having a long